Hello everyone and welcome back to the channel. In today's video, we'll learn how to interface a flex sensor with Arduino using Proteus simulation software. You'll see how the sensor's bending affects its resistance, how Arduino possesses that signal, and how the results are displayed in real time on the 20x4 LCD. By the end of this tutorial, you'll clearly understand how analog sensors like the flex sensor work and how to simulate their behavior accurately in the Proteus. Before we start building the circuit, let's first understand what a flex sensor is. A flex sensor is a resistive sensor that changes its resistance when bent. When the sensor is straight, it has a lower resistance, usually around 10 kilo ohms. As it bends, the resistance increases proportionally. This property makes the flex sensor useful in gesture recognition, robotic gloves, and a human motion tracking application. In Proteus, since the real flex sensor isn't available, we'll use a potentiometer to represent it. And to use this module, we'll have to first download this library. By rotating the potentiometer, we can simulate different bending levels of the sensor. So before starting the simulation, another step is remaining, that is to install three main libraries. That is the flex sensor library, as you can see here. The second one is the Arduino library for the Proteus, and the third one is the new LCD for the Proteus. Once installed, restart the Proteus so that both all the libraries are installed well and appear in your component list. So let's move to the circuit. You have to create a circuit as I have created the one. You can see this is the flex sensor. This is the potentiometer I was talking about. Changing its values means changing the resistance or the bend of the sensor, and in return the flex sensor readings are changed. The output here is connected with the analog pin of the Arduino module, and the whole values, the outputs, are shown here on the LCD. It makes this project very professional and easy to understand. So once this is created, it's time to go to the software part. We have to code the Arduino code according to our requirements. I have created one. This is the code, and make sure you have this library installed before you start coding. Once it is done, you can paste the code. Let's understand this. First of all, we have to include the liquid crystal library. It controls the output of the LCD and make these connections according to our simulation. After that, the analog pin is defined here, and this is the setup function. In the setup function, you can see here the LCDs, the introduction of the project is shown on the LCD. So first of all, it is the LCD is started, and if it has any output, it would be clear, and it will show these two messages, flex sensor test and Proteus simulation, in the start. It is a very good start if you are going to present it somewhere or want a professional project. After this, you can see this loop function. It all shows that whenever the value of potentiometer is changed, the resistance on the potentiometer is changed, the analog values are changed, and so the flex value is changed, that is shown on the LCD. This formula is the main, this is the main formula that converts the voltages into the analog signals, and these all are the values that you will see on the LCD. These if-else loops decide the change in the output when the user changes the resistance value on the potentiometer. So this was all the code. Now we have to connect this code with the simulation. So for that, we have to get the address of the hex file. Whenever the code is created and compiled in our system, a hex file is created, and we have to provide the address of that hex file to our Arduino simulation. So the easiest way to do so is to compile the code. After this loading is complete, it will provide you the hex file address automatically here. So let's copy this. Copy this without any quotation marks. Go to your simulation. Double click your Arduino. I have already added this before. This is the same address I have got. Click OK and make sure you have provided the address of hex file here too. This is the hex file that we have downloaded from this blog. So a hex file of the sensor was created and we have pasted it. So we just have to provide its address as I have done before and click OK. Hopefully the project is okay to test. Yes, it is showing you the output. This is the introduction as we have input in our setup function. After that, you can see right now our resistor has 100% value. So the resistance is maximum. This is our voltage. Voltages are maximum. So let's see what is its effect on the sensor. So the sensor shows that right now the flex sensor is fully bent. So bent level is high, voltages are same as shown here, and the analog values are highest. Let's change and see if with changing in the resistance value is the bent value also change. So yes, this is right now this is partially bent and here you can see the resistance is in medium. On the zero resistance, you can see the voltage value is 0 here and here too. Analog values are 0, voltage is 0, bent level is low, and it says that the flex sensor at the moment is the straight. So you can change the potentiometer values to indicate that the sensor is bent or not. This was the whole project and I hope it is clear to you. If you have any question, you can ask in the comment section.